Welcome and hello. This is a video tutorial in HEC RAS, and in this lesson, I'm going to be discussing hydraulic structures inside 2D flow areas. And by hydraulic structures, I mean weirs, gates, and culverts. So what I have on the screen here is my HEC RAS. This is the geometric data editor. So let me go ahead and bring up RAS Mapper here. You can see the terrain. And we have a river that's flowing south and southwest and then west. So what I'm going to first do is sketch out a 2D flow area. Oops, not like that. Previous zoom. Okay, there we go. Previous zoom for the save. And then I'm going to go back to the geometric data editor and talk about adding the hydraulic structures. Okay, so here is my geometry. It's called base. I'm going to begin editing. Click on 2D flow area. I want a perimeter, and I'm just going to go ahead and start sketching around the entire cross sections here, just being sort of hasty about this, and then double click. I'm going to call this 2D flow area 1. Okay. And then for the cell spacing right here, let's go ahead and just say 200 feet and generated that. That looks all right. We probably want to touch it up if we were actually using this model, but for demonstrating the hydraulic structures within a 2D flow area, that looks good. I'm going to go ahead and stop and say yes. Okay, save the edits. Now we're ready to go back to the HEC RAS geometric editor. So I'll go edit geometric data. It looks like our 2D flow area has arrived, and it's actually a little bit busy. Yours may be blue everywhere, and mine was originally. I went up to edit lines and symbols, and then for the 2D flow area, I went ahead and selected that, and then just changed the fill color to white. So this is what yours might look like. Go up to edit lines and symbols. If you want, select that 2D scheme 2D, and then just go ahead and select the color, or you can go ahead and manually change your RGB values. But I'm just going to go with white for the rest of this lesson. All right, so let's go ahead and back out. Yeah, it's still almost too hard to see the lines here, but we have the river in blue, this direction, and then the cross-section lines are in green, like this. But anyway, once we get the hydraulic structure added, it'll be a little easier to see that part. Let's go ahead and do that now. Up at the top, this is where we define stuff and create new features, such as this SA/2D connection button. So I'm going to go ahead and click on that. And what I want to do is sketch out a hydraulic structure that goes across the entire 2D flow area. Now, the minimum requirement is that the length of the hydraulic structure needs to span at least one cell, and that won't be a problem for me. But in the event you have a very small hydraulic structure and particularly larger cell sizes, that may cause a problem. So just a heads up there. I'm going to do a single left click, and then I can make multiple clicks. I'm going to keep it simple and just do one click over here and then one click on the right side. So again, I'm facing downstream and then sketching out left to right. I'm going to go ahead and just name this dam 1. Or actually, I did a dam 1 and dam 2 already. I'm going to call it dam A. So click OK. Here's my dam A. Now, if I zoom in, I see there's a black line that's bold. And what that is the original traced out version of my hydraulic structure, but it's conforming to the existing cell boundaries. You can also hopefully see a dashed line that goes straight across and does not obey the existing cell boundaries. That was the line I sketched out. And what we want is our hydraulic structure to follow that line. So we want the cells to actually adjust to this dashed line, not to what is currently black and bold. To do that, you're going to single left click on this dashed hydraulic structure line. It became magenta for me. And then we're going to go down here to edit internal connection break line cell spacing. All right, now we have a dialog box where we want to specify the minimum and maximum cell spacing. This is for the mesh that's going to be created just adjacent to this hydraulic structure. Now for the maximum, I'm going to type in 200 because that's what we used for all the cell spacing for the entire mesh. So I think that would be good. But for minimum, I'm going to go ahead and type in 50. So that is 4 times smaller. And what I expect to have is a row of 50 foot cell spacing adjacent to the line, and then a second layer out, 100-foot cell spacing, and then the third row and fourth and all the other rows 200 foot, which is what you're currently seeing. Okay. So I'm going to go ahead and click OK. Now for it to actually be enforced, I need to do one more thing. It's going to be a left click on that dashed line. It turned magenta for me again. And now I'm going to click Enforce Internal Connection as Break Line in 2D Flow Area. and boom. Now the cells have sort of been recomputed and resized. As before, we still have this break line, which is magenta, and I've got this context window kind of in the way. The first row has the 50-foot spacing. The next row has the 100-foot spacing, and then the third and all the other rows have the 200-foot spacing between the computation points and the cell length size as well, at least as well as it could. So this hydraulic structure line sort of serves as a break line. It has some similar properties that we've seen already. All right, so now I'm going to go ahead and click on this connection, which I've been calling a hydraulic structure, edit connection, and now it brings me up this editor box. I can also access this editor box by going over to the left side panel of tools and then clicking on SA/2D connection. But in that case, I'd have to make sure that I'm actually selecting the correct hydraulic structure, or connection data it's called. All right, let me bring this off to the side here so we can see the image. All right, what we have here is all of our data for that hydraulic structure, or the connection here. We have an optional description. We have the connection data, so from and to. Now in this case, it's from and to the exact same area, the same 2D flow area, but we know that the positive value would be when the water is flowing south or southwest across this boundary. We also notice that we have a center line distance of 5867, and that's in feet. And we even see a plan profile view or elevation station view, and this is looking in the downstream direction from left to right, where left is station 0 and then right is the 5867. We also have centerline GIS coordinates. I'll talk about that in a little bit later, as well as the overflow computation method. But what I want to do next is explore some of these hydraulic structures, which we can add. I'm going to add a weir and embankment. I'm going to put it across the entire length here. So 38 feet, 24 feet, 0 to 5867. Okay, just getting my bearings here. So I'm going to click on weir embankment. I'll bring this over here so I can kind of still see the data. For a weir width, let's go ahead and just say 50 feet. So that's in the direction of flow. And then we have a coefficient, broad crested weir. I'll go ahead and just stick with those numbers. I'll say we have a station of 0 and let's see, maybe 24. That'll be my minimum elevation. All right, I've added some numbers in here to the station elevation table. And once I click OK, I should see the preview show up over here. Basically, what we're doing here is, oops, I want to put that at 24. Okay. So what we do is we have a top elevation of 38, but then for 100 feet of width right here, oops, it's supposed to be 100 feet, so 2,500 and 2,500. Then we have a 8-foot drop, and then after that, for the remainder of the length, it remains at 38 feet, and then back down to 24. Okay, so I'll click OK, and then boom, here is the preview, you may call it. Here is a little weir that I sketched in, and then I can even zoom in on that weir if I wanted to make it look more normal. So we have an 8-foot drop, and then it's actually 100 feet wide. So it looks deeper than it is wide, but that's just because the scale is off. This is much wider than it is deep. All right, so that is the weir embankment. We can also add gates, culverts, outlet rating curves, and time series outlets. I am going to, for the sake of demonstration, go ahead and add a gate, but I would mention that if you're curious about the details on all these methods, check out lesson 8 in this playlist. It's geometric data, inline structures. I'll leave a link to that lesson in the description of this video. All right, so I'll go ahead and click on gate, but before I do, I want to kind of look at what I'm doing here. So I'm going to zoom out, or let's go zoom full plot. Let's put the gate at that, what was it, 2400? I'm going to zoom in on just the, I'm going to put it below the weir. Yeah, so maybe 25 or 26 and just make it a few feet high. And that's between station 2400 and 2500. Gate, I'm going to type in some numbers here real quick without explaining it too much, but the height we'll say is 5 feet. Actually, let's go ahead and make it 4 feet. The width, we'll say they are 10 feet wide. And then the invert, we'll say is, how about 25? Okay, let's go ahead and add some gate openings. So I'll call this gate opening 1, and it'll be centered. So we'll just put that at 2450. That's the center line station. I've added gate openings 2 and 3, and that is on opposite sides of the center. So 2470, 2430. I think that's all I need to do for here for now. So I'll click OK. And now, yeah, it looks like they showed up here, but I have to zoom in again if I really want to see it. Yep, so those are my 3 gates right there. Let's go ahead and check those out in the plan view in the geometric data editor. So I'll go ahead and close this editor and then zoom in to where I think they are. Here they go. All right. So we have our three gates that are in this inline structure, or it's not an inline structure, but it's a weir embankment in the as a hydraulic structure inside of the 2D flow area. Excuse me. And as with other gates and weirs, there are boundary conditions that we can assign to these gates, for instance. So to do that, we'd go up to Edit, Unsteady Flow Data. And I sketched in the dam one, but I did not delete that. So never mind dam one. We're dealing with dam A. That's the hydraulic structure. Our options here are the gate openings, elevation control gates, and rules in the Unsteady Flow Data Editor. Okay. More information on that is in lesson 23, where I talk about unsteady flow analysis, boundary conditions, and I'll leave a link to that video in the description of this video. All right, there's a few more things I wanted to point out in this hydraulic structure editor. So let's go back to the editor here. We have a button here for breach plan data, and I already have a lesson on levee breaches. I'll go ahead and click that, but basically here is the cross section of the embankment that we created. We can use the tools here and define what the breach should look like, when it should breach, how it should breach, and of course this checkbox is whether or not it should even breach. So that's where you would define a breach in this hydraulic structure. I have to close this as well. Also, we have overflow computation method. Our options are normal 2D equation domain. So if I go ahead and click that, that's if the flow is computed as a 2D flow between cells. So that's one option, but you need to make sure that if you select this option, then my notes say that don't use this if waterfall, which means you don't want to use this first structure if the water is going to flow freely, fly in the air down to the downstream end. This should be more for submerged flow simulations. And then the other option here is for use weir equation. You can use this for any situation, and this is the default. So I'd probably just go ahead and use this one. We also have options for structure type and then gate flaps. So for instance, if you're using culverts, if you want to put flaps to prevent flow in one direction or the other, you can go ahead and assign it that way. We're using gates though, not culverts. Also, this image right here, we have a line that shows the existing ground terrain. And if I click it, I think it's supposed to, hold on a second. There we go. So it's now highlighted in bold and red, and we can actually zoom in and get some more detail on what those actual points are, in case you're curious of what the ground level is underneath this hydraulic structure. Okay, so right there, I got a pop-up. It gives me the station and elevation value of 1328 and 32.82, which is this one right here. All right. Also, centerline GIS coordinates. This is where I can specify the centerline coordinates of that hydraulic structure, which I traced across. Now, I just traced one large single line across, and that's why you're only seeing 2 points defined, but we can add more points. So I'm going to go ahead and do that right now and also demonstrate the GIS features and the coordinates that can be assigned to gates, openings, and culverts as well. I'm going to close this, and then let's go ahead and zoom out. We're staying in the geometric data editor. I'm going to create a new storage area slash 2D connection. And just like this one, I'm going to go all the way across. So kind of boring to start. A single left click and then another double click to finish it off. We'll call this dam B. Click OK. Now, say for instance, I wanted the curvature to be different than just a straight line. The quickest way that I've found to do this is to just hold down the control key. Now my cursor right here is sort of a crosshairs and measure tool icon. And I'm just going to do a single left click to start. And then I'm going to click, 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 click. I'm just going to let go of the control key. And now I have my points. These are the vertex points that define this, I'd call it an S-shaped curve more or less. So what I'm going to do is copy those coordinates to my clipboard by clicking this button. Close this dialog box. Now I want to zoom in, a single left click on this straight line that I sketched out originally, edit the connection, and then click on this centerline GIS coordinates. So I click on that. Instead of just the 2 points, I'm going to go ahead and delete that, highlight both columns, Control V to paste, and these are the points that define that S-shaped curve. So if I go ahead and click OK, here is now my S-shaped curve, but this is not just some random line. This is the actual hydraulic structure that I'm going to define. Okay, let's do what we did before and then click on this Edit Internal Connection. I'm going to go with 50 and 200 once again and click OK. And then the next step is to enforce that internal connection. And all right, great. So it looks like we have another break line, but this is going to serve as an embankment once we go ahead and add in the weir and embankment data. All right, so the last thing I want to do in this lesson is talk about the XY coordinates using GIS tools, but for the gates that we already sketched in dam A. So that was dam B. I'm going to leave that behind us. Here's dam A right here. We put these gates in just by station values. Let's say, for instance, you wanted to freehand the location of these particular gate openings within the weir embankment. You can do that as well. So this one right here has the smallest station number. I'm not sure what we called it, GO1 or GO2, but let's go ahead and move it over this way. So to do that, I could type in numbers, but I'm going to go ahead and just record the numbers again, holding down control using this measure tool. I'll go ahead and do a single left click here, and then I'm going to move the mouse, let go of the control key, and now right here is my XY values. So I'm going to go ahead and copy those to my clipboard, close. Let's go ahead and open up the editor by clicking on this button, select dam A. Okay, this is the one that we've already made these edits to and added the gates. So the gates you can kind of see are down here. I'll click on gate, and now which one had the smallest stationing? It was GO3 apparently, so 2430. What I'm going to do is come over here to the GIS area and then just highlight as many cells or more that I have on my clipboard. Control V, pastes them in. That looks good. And if I'm curious, I want to see individual gate center lines for all the gate openings. I can click this button right here, and it gives me this table. This is also true for culvert openings. So if I click OK, and then I click on culverts, we have the same sort of interface. I'm not going to add a culvert, but just so you know, we have different barrels and then the GIS data and then the individual barrel center lines instead of gate openings. Okay, well, let's go ahead and check out what changes we made and make sure that they're correct. I'm going to zoom in here on dam A, and sure enough, this this gate opening has moved over and has actually extended to the actual coordinates that I specified. So we do have coordinates that show up in this bottom right corner based on wherever my mouse cursor is. So there's nothing stopping me from just writing it down on a piece of paper or somewhere else and typing it in, but using that tool where I can actually measure the location, that's probably the easiest way to go, or at least to get started. All right, well, that was the end of the lesson. We talked about hydraulic structures inside 2D flow areas. We went ahead and created a couple hydraulic structures, defined the weir embankment, added gates, and then experimented with a number of other features, such as using the GIS coordinates to define locations.